Okay, so let's go ahead and do some machine learning. But the first thing we have to do is separate our data into training set and test set. So let's go ahead and I'm going to go ahead and add another cell here. And um, I also want to save myself some time later on. So I'm going to copy this. I have X vars and Y vars up here, where I've listed out my independent and dependent variables. And I'm going to want to refer to these often in what's coming ahead. So having variables with these lists in them is going to be useful. It's going to save me some typing. So let's call this input vars, and I'm going to call this output vars. So the input vars are going to be the independent variables that I use to make my prediction, and the output vars are going to be the dependent variables that I'm trying to predict. And these are actually going to be constant, so let's go ahead and make them constants. All right. And then to make the training set, I imported train test split already from SciKit Learn. So let's do iris train comma iris test is going to be equal to train test split. And then I'm going to split the dummies set of all the irises. And then I can specify some parameters. I can specify what percentage of the data I want to use for testing versus training, and then a random number seed. So for test size, let's do 20%, which is 0.2. Do 0.2. So that's going to be 80% of the cases are going to be training, and 20% of the cases picked at random are going to be test. And since this is picked at random, if I just run it like this, I'm never going to get the same results twice. And sometimes that's fine. Sometimes you actually don't want the same results twice because you want to run the same algorithm multiple times and either take some sort of composite over it, or basically when you're scoring how well a training method works, you train the method on a set of test cases, and then you score it on, you train the method on a set of training cases, and then you score it on some test cases. And then you do that again with a different randomly selected set of test cases and a different randomly selected set of test cases. And so if you do that a bunch of times, you can come up with an expected overall range of accuracies that you expect to get using that particular training method. But here, we do want this to be reproducible because we're going to be messing around with various things and rerunning our training methods multiple times. And we don't want the results to suddenly change at random. So we want to get the same sequence of random cases each time we run this. And the way you can do that is by specifying a random seed value, which is called random state. And then you can give it any number basically, and it's going to specify which sequence of pseudo-random numbers you're going to want to use to pull your training set and your test set out. And so I'm going to use 42 because that's the answer to life, the universe, and everything. And then this is going to give me two sets, so I can display iris train and display iris test. And both of them should have, they have my classification columns and my original data columns. So the training set has 120 rows in it, and the test set, that's like 30 maybe. let's figure it out. So I'm going to display length of iris test. Yeah, so I ended up with 30 test cases and 120 training cases.